we find in most of the cars of today. Like most of the cars today already come with like self-driving level 1 features, and so they come with the radar, or use the radar for having a better perception. However, we want, we strongly believe in vision, and we are moving away from using the radar at all.
What's the distance horizon for the radar? How far out can the radar see right now?
Really? Well, so that's a limitation that can be car specific, because it comes with the car.
Yeah.
120 meters is kind of like the minimum that can see.
Is that 120?
120 meters, so
okay.
It's like 135 yards. It's like the minimum that those radar can see. But I mean, like usually they go up to 150, 160, 180.
Okay.
But then, like, what is the purpose of like seeing so far, right? It becomes like, even if you see a car, when it's like 180 meters away, it becomes very hard to understand, is it a car that is, for example, like in my lane, or it's not? Like when it's like so far, I mean, okay, if there is like a concrete wall 180 meters away, you won't see it, right?
Mm-hmm.
But like, if you just care about like understanding where objects are, and are there objects that they should care about or not, then when it gets so far, it becomes like hard or like meaningful.
Okay.
So just out of curiosity, so I'm looking at the list of supported cars. I see Chevy Bolt and Prius, which has has an electric or hybrid drivetrain.
Yep.
Just kind of curious, is there any real difference between developing openpilot for a car that uses an internal combustion engine versus like electric, or is it more or less the same?
Well, so it's pretty much the same. Like everything is the same. As I said, like if we go back to the slide about how openpilot works. This one. So pretty much everything that you can see from half of these and beyond is the same, except like few parameters that might affect how you generate like the planning. So okay, if you have a bigger car, we currently don't do this, but like imagine like you have, well actually we do. We might change the way that, for example, you generate the planning if your car is bigger or smaller, has a longer wheelbase, etc. But like except few parameters that define this physical size of your car, everything that comes before controls is abstracted from the specific car. Things that come after controls and have to do with interfacing with your car, it can be car specific, and generally like going back to your question, how much does it change if it's combustion engine or like electrical? Not really. We found that cars that are hybrid are a little more pleasant to control, because like the electric motors doesn't suffer off like the delay of the combustion engines. It's a little easier to control, but it's minor things.
Okay, cool.
Yeah. Anybody else?
Awesome. So, the thing that I'm thinking about is, and this is me and my craziness, and doesn't have to do with a whole lot with the self-driving car part, but with the attention measurement that you're doing, where you're looking at the person's face.
Yeah.
One question I have is, what's your method right now of doing that? Are you looking for, you sort of train on a baseline of 80% of the time somebody's looking in this orientation, and so they deviate from that for a certain period of time, and you sort of have a weighting algorithm, and finally when it trips you say, okay, you're not paying attention because you haven't been doing what you usually do?
Well, so it's kind of like abstracted. Like usually we found that we iterated on the algorithm, and we found that actually people that pay attention to the road, they look straight. Like you just look straight. Like your head is literally like kind of like your eyes, like your head is like perpendicular to the road.
Yeah.
And we found that to be kind of like the most usable and best indicator that
makes
you're
it
paying
easy.
attention, and that makes it easy. But so what we do is like we track like the angles, like how your head is oriented, and then we have like thresholds over that depends like on time for how long you're distracted, and how badly like you are distracted, how badly you're looking away. And so we combine all those things, and we have some sort of like threshold to issue like the warning. And it makes it easy because it's not, for now, it's not like dependent, for example, like on like eyes, or like where you're looking. Because so for example, like if you have glasses, sunglasses, it still works. However, we want to make it better, and when possible, start to track eyes as well. Like you can, like if you, those systems are really not meant to be not cheatable. Like if you want to cheat the system, you can. The point of this system is that they should remind you how you should be behaving, right? And But still, it doesn't mean that they shouldn't be better than what they are. And so, yeah, we want, like, if you don't have sunglasses, you should be able to track the eyes movement, where your eyes are looking at. And so they are supposed to become better. But for now, it's like mainly like head orientations, how far from the road you're looking at for how long.
Okay. And is that, all that module, is that abstracted away from all of the rest of the openpilot stuff enough to where, you know, you could install that in a vehicle just to get those alerts?
Yes. So, okay, to clarify, this is a very good point. I think I should totally clarify this. So, the Eon, the comma Eon, which is like the platform the hardware platform that we sell, it's by default doesn't drive your car. It comes with the driver assistance feature that is called passive driver assistance features. So it warns you if you're about to collide with the car. So it has forward collision warning, and it has driver monitoring. It has like speed sign recognitions, things that we can just leverage without having to interact or like control your car. In addition to that, the Eon can become a development kit, and you can reinstall on it software that is called like openpilot, which is the open source software that can actually like drive your car. Actually, both software stacks, they are pretty much like very similar to each other. Like the software that comes default with the system and openpilot, they are very similar to each other. They are both open source, and so yes, you don't need to have like a system that actually drives your car. If you just care about like a system that tracks your attentions, works as a dash cam, so records your drive, both driving drive, like the road and the internal of the car, and so yeah, you can you don't need to use the specific driving features if you just care about the monitoring features.
Okay. And are there any sensors that you're reading off of the CAN bus that you absolutely have to have?
No.
Or are there so you could actually have it completely separated from any of the electronics of the car and still get some of that?
Well, yeah, you still get
monitoring,
like,
at least.
Yeah, monitoring for sure, speed sign of course, because like they just rely on like GPS. Like we have like GPS sensors inside the system.
Like what, Open Maps?
OpenStreetMap.
Yeah, OpenStreetMap. That's what.
OpenStreetMap. Yeah. We use OpenStreetMap. No, it's like let's say level one, step one is like you just have the ear like in your car, and it's not connected to the CAN system of the car, and it just works as a dash cam. It still like do the driver monitoring, forward collision warning. That's all works. Then step two is like, well, you have a supported car, you connected to CAN. Still, you don't take advantage of the driving features, but things are a little bit better because you take care of like you know exactly what the speed of the car is, etc. Then the next step after this is like, well, you actually install OpenPilot, and you have the system actually driving your car.
Okay.
So it's a sort of like you can get like 3 different things from the system.
Sorry if I missed that. I came in a little late.
Was that?
Sorry if I missed that at the beginning.
No, I didn't say it actually. So
Okay.
thanks for asking. Yeah.
So in some cities with poor infrastructure, such as Albuquerque, you may have noticed some of the places you can barely see lane markings, and street signs are missing or knocked over, stuff like that. How well will the software be able to learn to adapt for things like that, or are you just going to have to take over any time that the city you're driving in has bad infrastructure?
Well, so we do, right now, for example, we are relying on lane lines quite heavily. Like the system can kind of drive without lane lines, but it doesn't do like a great job yet. It's getting better. So it's getting, over time, it's getting better. It's getting like it relies less and less on actual features like being present, like pretty much like a human does. Like a human can drive
Right.
if you don't see.
Yeah, I mean,
But-
obviously, if one of us are driving and there's no lines, we can kind of extrapolate from where everyone else is, you know.
Yeah, exactly. So right now, I would say like it kind of depends on like, for example, like lane lines safely. But I don't know. I didn't find Albuquerque like particularly bad in that sense.
Maybe you haven't been to some parts.
Probably, yes. Yes.
I came down Old Route 66. There was a park that had no lines for probably a quarter mile. It identified the sand on the side as the right line. Just the color of the dirt out here happened to do that. So.
Yeah. So.
I
So-
drove to LA. I drove from Virginia to LA and back to your home.
The way that we're teaching the system to identify lane lines, it's a little bit abstracted from the specific lane lines is, but the next release is like of the system, which is like what actually Harald, like our engineer, is working on, is actually to specifically other than the lane lines, determining what is drivable and what isn't drivable. So if you are like on a road where like there is no lane lines, the system will be able to specifically understand, okay, this is like a barrier that doesn't have a lane lines, but I know that I should be driving here. And so it's going to get better at driving in situations where basically there is no like lane lines. But I mean, it's already like in certain situations it kind of works. Yes?
What's the barrier to scale deployment of this?
Yeah, it's good. Great question. So we want to engage with OEMs and tier 1 suppliers. We want to ship openpilot in products in large quantities. So as I said, like our mission is to have openpilot becoming the Android of self-driving cars. So we want openpilot to become like the standard for self-driving level 2 systems. And so yeah, we are like absolutely open to discuss with anybody who's like serious about like implementing openpilot. Like openpilot is, as I said, like it's pretty much like completely open source. So you can see what it does, you can see what it is, you can see how it drives. It's very easy to access it, to test it. So anybody who's interested into actually shipping it, the idea is like at that point to license openpilot for commercial use in large quantities.
So then the follow-up is, what's the conversation been so far with OEMs in Tier 1?
Well, so we have discussed with many of them, and it's an ongoing process. I believe that as of now, we still have to do some more homework and like making the system better. But like in parallel, yes, we are open to discuss. We have done in the past. We want to keep doing it. But yeah, I think there is a little bit more homework that we need to do first. But the two things can go in parallel. So yes.
In your list of supported vehicles, the different cars have different lower speed limits where they lose steering or acceleration functionality. Is that a sensor limitation or actuators? And do you see, is that improving? Are the cars getting better at that, or what?
Definitely cars getting better. The point is that certain cars, like we have to communicate with the cars. So we are like, as I said, everything is kind of abstracted from the car, but then at a certain point, the last layer is like car dependent. And so we have to obey to whatever are the constraints of the specific car has. So if the specific car locks you out for controlling like the brake, the steering, for example, below 10 miles per hour, then there's nothing we can do about that unless you basically like change the firmware of your cars, which we don't want to do. And as I said, like the point of openpilot is really like creating something that has to deal with limitations that are car specific. At the same time, the important thing is that openpilot itself is capable of handling that situation. We care about like having an openpilot, like a software that is actually abstracted and very general. And then of course, like every car has its own limitation, and we are forced to obey to them. But the more we move forward, the less those limitations are present, because cars that ship now are less limited than cars that were shipped like a year ago or 2 years ago. Like every car pretty much like by default tends to have adaptive cruise control with stop and go. So it means that they can have braking and gas controllable from 0 speed to whatever speed, like 90, 100, 110 miles per hour. So the direction is definitely like more capable cars, which we actually is totally aligned with the capability of openpilot. So cool. Yes.
Right. Ask one more. The data that you're streaming out by CAN.
Yeah.
How standardized is that from one model to the next, or specific sensor to the next? So like if you're reading, let's say, speed data or radar, how drastically different is it from a Toyota to a BMW or whatever?
Okay. Well, so among the open source repositories that we have, like openpilot is one of those repositories, like software, let's say software bucket, where you can find like a complete like set of features. We have another open source repository that is called like OpenDBC, where so the DBC file is like the file that describes your CAN data. Describes how your CAN data are like structured, right? And so this is like car specific, mainly car make, and then within a car make, almost every car are very similar with each other. We have like so imagine like to have one file per car. Those files are all very similar to each other within the same car make. They are drastically different within different car makes. So the DPC file for Honda is very different from the DPC file from Toyota, etc. But this is like another open source project that we have. Like we are reverse engineering this like CAN communication, and we understand ourselves what things mean in the CAN in CAN. Yeah.
Cool. Well, thank you guys so much for coming. We have a mobile store if you are interested in purchasing a tour t-shirt that's one of a kind, only you can get on this tour. We also have the Eon that Riccardo talked about, some sweatshirts, and we'll be around if you want to ask us questions. We got Eddie, Harold, myself, and